In the next 3 videos, we will be going into basic details about parts of the central nervous system. This is the first of the series. As we know, central nervous system is made up of spinal cord and brain. Both brain and spinal cord develop from the neural tube. Neural tube develops during the 3rd week of intrauterine life, extending from the procaudal plate to the primitive node. From this simple cylindrical structure, over the next few weeks, a complex central nervous system develops. Without going into all the details of development, let me just introduce you to a few salient points that we need at this juncture of our journey into neuroanatomy. From the primitive neural tube, the caudal half persists as a same tubular pattern, and that is what is going to contribute to the formation of spinal cord in future. Whereas the cranial half of the neural tube shows the development of 3 vesicular dilatations, namely rhombencephalon, mesencephalon, and prosencephalon from the caudal end to the cranial end. Prosencephalon soon forms 2 subvesicles, telencephalon and diencephalon. Telencephalon grows much faster and divides to form 2 vesicular outgrowths forming the cerebral hemispheres. Diencephalon contributes to the formation of thalamus, hypothalamus, subthalamus, epithalamus and neurohypophysis. Olfactory bulb and tract grow as an outgrowth from the telencephalon, and the cavity of the neural tube in the telencephalon region will form the lateral ventricles, 1 each in each of the cerebral hemisphere. Optic cup and tract develop as the outgrowths from the diencephalon, and the cavity of the neural tube at the level of diencephalon forms the 3rd ventricle. Mind you, there are 2 lateral ventricles, so this gets the name as the 3rd ventricle. Mesencephalon will form the midbrain, and its cavity will be the cerebral aqueduct. Rhombencephalon again divides into 2 subvesicles, metencephalon and myelencephalon. Metencephalon will form the cerebellum and pons. Myelencephalon contributes to the formation of medulla oblongata. Inner ear develops in this region, and the cavity of the rhombencephalon is the 4th ventricle. The caudal part of the neural tube persists as spinal cord, and its cavity is the central canal. Neural tube at the beginning of its development is lined by a single layer of wedge-shaped cells. Soon these cells start proliferating so that the neural tube will be lined by pseudostratified epithelium, which will soon get transformed into multi-layered or stratified layer. Mind you, these cells have to multiply to form approximately 10 billion neurons, because as we know today, not much of cellular multiplication happens, or not any cellular multiplication of the neurons happen after birth. So the quick multiplication of these cells result in the neural tube developing 3 layers from inside outwards. They are the matrix layer, which is the innermost layer of single layer of cells, and these cells will form the ependymal cells which line the ventricular cavities. The next layer is the thick layer filled with multiplying cells. The first batch of these multiplying cells will be the glial cells, and the second batch of cells which are formed, they will be forming the neurons. So this mantle layer will contribute to the formation of gray matter. Soon these neurons will start sending their processes outwards, and that will result in the formation of marginal layer, or which will contribute to white matter. This primitive design is retained in spinal cord almost entirely. With some modifications, it is also retained in the brainstem. In case of cerebrum and cerebellum, The cells from the mantle layer will migrate to the area which is just beneath the pyometer, and there they multiply much quicker and form a thickly populated layer of neurons forming the cortical layer. So both in cerebrum and cerebellum, the outermost layer is the gray matter, which is the cortex. Inside that is the layer derived from the marginal layer, that is white matter. And what was mantle layer will contribute to a small collection of nuclei. In case of cerebrum, they form the basal nuclei. In case of cerebellum, they form the intracerebellar nuclei. Thank you. Hope you enjoyed this video. We will now proceed to the